Hello, good evening, everyone. Ouch, sorry. Hello, good evening, everyone. My name is Daniel Alayode, and I'm the Google Developer Student Club's lead for Ahmadu Bello University, Nigeria. And it's actually great to be back here to have this session together with every one of us. I know it has been a while, and we are all back on. And one amazing thing about the session as well is it's not just GDSC ABU, it's also GDSC. Sorry, give me some seconds. Sorry. Oh, I'm trying to admit some people. Sorry. So I have this incoming. All right. Yeah, sorry. Sorry for the short what do we call it? Sorry for that distraction. So like I was saying, the beautiful thing about this session tonight is it is hosted by both GDSC Ahmadu University Nigeria and GDSC BUEA Cameroon. So don't be surprised you'll be seeing some Cameroonians, and don't be surprised if seeing some Nigerians. So we are all family, and yeah, and we are all together. So I want you to do something for me. While this session is going on, I want you to introduce yourself, your name, your school, what you hope to learn from this session, and just introduce yourself basically in the chat session. Let's try to connect one another, try to get to know one another. And I know the session promises to be amazing because see our facilitator is around. You can see his class and everything. So please in the chat session, so please just let's start introducing ourselves. I won't start until we start doing that. So please introduce yourself, your name, your stack, your school, what you hope to achieve from this whole session. So please, I want to start seeing that in the chat session. So before we begin, I've not seen anybody introduce themselves. So we won't start. No, no, I didn't say you should unmute yourself. So I just needed to type it in the chat session, please. Please, yeah. Um, let's introduce ourselves. Are you guys shy? This is a Google Meet meeting. Please introduce yourself. Type it in the chat session. Your name, your school, where you're chatting from, what you hope to achieve, that kind of thing. Not just your name, your school, probably your stack as well, probably your level in machine learning. Are you a beginner, intermediate, professional? Which other one is above professional? Pro professional. So okay. So I can see some people introducing themselves. So I'll just go right away. So basically this is Explore ML. Oh yeah. Oh, awesome, awesome. I can see Anid Abdurazak from Polytechnic of Ibadan. That's amazing. That's amazing. I'm glad to see that we have people from other schools join us as well. So this is really, really amazing. Okay, I can see Umar, Lawa, Sonny. Oh, nice, nice. I can see Precious Daniel from Cameroon. Oh, that's awesome. Welcome, Daniel. I can see Abdul Semiu Sadiq. I can see Candila Bell. I hope I pronounced that well. Beginner in ML. Oh, awesome, awesome, awesome. So yeah, so why the introduction is going on. So I would like to basically introduce you what the whole session is all about. So this is Explore ML, and Explore ML is an initiative by Google to actually train students in universities on, just like the name implies, explore, just to explore ML, to explore machine learning. So when before I got to know about machine learning, I used to think about, okay, what is machine learning? Is it that, okay, my computer will just start working and start learning or something, or how what does it even make? It doesn't make sense. How do you say my computer will start learning? Is it watching me? Is my computer watching me? Is it those kind of things? So all this so basically this session is just all about that. It's just here to explain basically all you need to know about ML, and I promise this to be amazing, and it's going to run for 3 weeks, and we'll be having several sessions, and we'll be having hands-on activities where you'll be given some tasks to do. So while we are doing this, we want you to be engaged. We want you to also try to do this, and then you also have the access to our facilitators, ask questions directly, and get to have like practical experiences on how to actually go about this. And yeah, before we move further into what we the agenda for tonight, because I think I'm taking much of our time, so I'd like to introduce Shekinah. She's the Google lead for. In fact, don't let me introduce her like that. She will come and tell you about herself. She's an amazing person, and she's someone I really love. We've not met in person, but I know we'll meet someday. So she's someone I really love to meet someday. So, but regardless, just be, maybe sometimes you just see us together. But anyhow, over to you, Shekina. Please come on board. Thank you very much.
All right, good evening, everyone. Daniel, thank you very much. Even though I don't know what you were saying. Okay, good evening, everyone. I'm called Shekina Mani, and I'm the Google Developer System Club lead of the University of BUEA. And I'm really excited to have this session together with the GDSC ABU. And I really hope that at the end of the day, we get to learn more and possibly connect with other people and expand our network. So, well, basically, that's me. Um, yeah, that's me. Yeah, over to you, Daniel.
All right, awesome. So, one thing you should also know about Shekinah is she's a React developer, and she's very, very good at what she does. She's a programmer. She's not just a lady like that. She's in Nigeria we call her Hagba. She's an Hagba. That means a professional, someone you look up to. So yeah, so that's that about that. So now we'll be introducing our facilitator. His name is Dairo Ibrahim, and he's going to be taking us through this journey. You can see he's also an Agba. He's also a great guy and very good at what he does. He works. He's not just a machine learning engineer by theory. He's also a machine learning engineer by practice. Like he actually works in real time, and he has gathered quite a lot of experience. So tonight he's going to taking us through the introduction, machine learning, and all that we need to know at this we go in process. So over to you, Dairo.
Yeah, Daniel, thank you very much for that wonderful introduction. My name is Tahiru Ibrahim. I'm the machine learning slash data science lead at Ahmadu Bello University here in Nigeria. I will be facilitating this session and a couple of other Explore ML Jam sessions. So I think, Daniel, are we going to go through the overview of the entire program, or should we just get started?
Okay. you can just get started. I think I skipped that while I was rushing. So let's just get started. We can come back to that later.
All right, fine. If you could give me a couple of minutes, sorry, a couple of seconds to get my screen up, I will now get out of your way. Okay, one sec.
You stop sharing your screen, Dairo. So I don't know if
Yeah,
you're
I'm aware.
no.
Is
All
it?
right, all right.
Interesting. So just give me a couple of seconds, please.
All right. So while he's trying to get himself trying to get things in order, so I would briefly taking us through what we'll be covering in the 3 weeks. So, like I introduced earlier, the study jam is meant to last for 3 weeks, which is like we'll be having 2 sessions per week. I'm sorry I can't share my screen now, but I just hope you follow along. And it's going to be starting May 19th, which is today, and it would end June 21st. And basically, we'll be having the sessions on Google Meet, where we'll be going through a lot of that, and we'll be having facilitators take us through each session. So for today, basically, we are just here to introduce the study jam to you and also share the schedule with you and explain its structure and the expected outcomes and all that you need to know. Also, as regards after this training, there will be certifications and there will be a lot of practical sessions where you have to yeah, you have to get your hands dirty basically. So you don't just learn, because I believe that it's not just about learning. It's also about doing. If you don't do and you just keep learning, you end up forgetting all you learned. And also participants will be evaluated through the assessments. Like there will be assessments, so you'll be evaluated. So be ready for work. Be ready to work. Because we want to ensure that you learn, and we want to make sure that, because if you do not learn, then there is no point having this whole study jam and all. Yeah, and there will be, like I said earlier, there will be certificates for people, for participants, and there will also be rewards and several others. So please follow us up on this journey. Dairo, are you back on?
Yes, I'm here now, and I think everything is in
All
order.
right, all right, over to you.
All right, so apologies for the little hitch, but I think everything is back in order now. So we're going to get started right away because we've wasted quite a bit of time. Um, so we're going to start with a very, very, very beautiful video from Oxford Sparks. And in this video, they try to give you an introduction to machine learning. So let's watch that together. Press play on it.
There's no audio. No
There's
audio.
no presentation audio. I'm sorry.
Can
Yeah,
do
Yeah.
almost nothing for ourselves,
Okay,
but
it's
soon
working now.
we're
It's working
learning.
now. It's working.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, within a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Wow. Okay. That was a lot. So does anyone want to tell me what they think with that video, with the information from that video? Does anybody want to tell me what they think machine learning is? I should also mention that this session is meant to be very, very interactive. You'll see why what I'm talking about later on. So please get ready to interact with me and unmute your mics and tell me what you think machine learning is. Please, someone don't start calling names, but all right. Go ahead. I can see your hand raised. You could unmute your mic and
All right, good evening, everybody. Um, Based on the video I watched, I can say machine learning is the act of a machine or a computer, let's say, per se, learning to bring out results due to data that has been fed to it before. So it's able to learn from what has been fed to it before to give you data, to big data in the future.
awesome, awesome. I love that definition. Is there anyone else that wants to give it a go? Go ahead, Mohammed.
So, from the video, machine learning is the ability of a computer to use past data or experience to predict future outcomes.
Thank you very much, Mohammed. That's correct as well. Is there anyone else that wants to tell me what they think machine learning is? Daniel, what about you?
Hmm.
When
Why
we
did you
when it
put me
comes
on the? Okay, I think someone is talking.
Okay, okay, Samuel.
Say again now. Or if na elderly people now, wey already know, I go only tell you sef. But me, I don't see any reason for your cheating.
Daniel, could you maybe? I think you're muted there on accident. To anyone else? Simpa, I could see you typing. Do you want to tell us what you think machine learning is? Or anybody else? We'll take the last. Okay, yeah, go ahead. I can see Uwe Dan's hands raised, so please go ahead. Okay, seems like you're here with us. Anyone? Okay. Um. So I will tell my
All
own
right.
version of what I think. I'd say my own version of what I think machine learning is. And if you know me, I love to picture fictional scenarios and link them to what I'm trying to learn. So if you ask me, we can imagine ourselves in the Bat cave, that's Batman's cave, and for some reason, Batman is allowing machine learning engineers to go near his computer, the Bat computer, right? And so, machine learning basically is so you meet Bat computer, you say, "Hey, Bat computer, I have a task for you, right? Um, I want you to do this particular task for me. What is the solution that you like? What are you like? How are you going to solve that issue?" So this is how it will go. Basket, the first guess that Bar Computer is going to take is going to be at random. It's going to be pure gibberish. It's going to be a random guess, right? It's because you're coming with something it has no idea about. It's never seen it before, right? So it's going to give you random gibberish. So you look at what Bad Computer gives you. Sorry, could you mute your mic? Okay. So I was saying Bass Computer gives you that random prediction, that random solution to the task, and then you say, okay, no, 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 this is not possible. Um, you're giving me random stuff. So I'm going to give you a hint. I'm going to give you examples of previous solutions. So you give that to Bad Computer, and it goes and it tries to learn from those examples, right? It tries to model so it changes its guess now. Its guess is no longer random. It has something to work with, which is the data that you give it. So it refines that guess, and if it's going in the right direction, it looks and said, "Oh, okay. It looks like this thing I'm doing is improving my solution." This is all done without your interruption as the user. Okay, so it keeps on improving. It says, oh, okay, this particular thing I'm doing is improving my solution, is making it look more and more like the real thing. So I'm going to continue doing that. So once Bad Computer is confident about its prediction, it comes back to meet you. It says, hey, I have the solution for you. By that time, if you are impressed with what Bad Computer has been able to figure out on its own, you give it a pat on its head, and yeah, basically that's what I think machine learning is. So it's that process of the computer learning to solve things without you having to tell it, oh, this is what you need to do. No, it improves by itself, right? So we're going to see a very a very interesting application of machine learning. right? It's a very very fun thing that Google came up with to help researchers in machine learning. So it's in a form of a game. Uh, you could go on to this quick draw link right here. This link here, I'm going to copy it and paste it on the message box in the meeting, and basically just play the game, have fun, and then come back in 5-10 minutes and we're going to discuss. Please, everyone, try and do that. Just click on the link, go on and interact with the game. Tell me what you what's your experience like.
So basically I think you meant to say 3 minutes so that we can, we can be quick with this. So please let's do that on time. So that we can come back on time, and so quickly let's go to the link. The link has been posted. So yeah.
Okay. Um, I think 3 minutes are up. Simpai is done. Okay. So coming back. Yeah. Drop a comment if you're back from the game. Awesome. Awesome. Okay. So very quickly, Nafisa says she didn't get any wrong guesses. Yes. So, very quickly, what do you think? What do you think happened? How do you think they made this? There was some voice that was trying to guess what you were drawing, right? And when you someone says Great Wall of China, awesome. So, very quickly, if you could type what you think happened, or if you want to quickly tell me on try to unmute your mic and let's discuss. What do you think happened very quickly? Yeah, go ahead, Muhammad.
Okay. What I think he's doing is that he's trying to learn from each stroke. Someone is trying to draw something, so he's learning from what you are trying to draw. Then I think he has data of maybe past drawings. Then it will try to match with those data. Then if what you drew is correct, then it tell you it's correct, and if it's not, it will tell you it couldn't guess it.
Yeah,
So
I
that's
I
basically
like I love your answer, honestly. Okay, anybody else again wants to try? I love that answer. Okay, I can see someone on the chat saying it's trying to guess what you try to draw. Yes. So, thing is, there's a large amount of data used to teach this game how to recognize images. Okay, so if you go to let me drop the second link. If you go to this link, you go to that link, you're going to see tons of examples of all the objects that you saw. So I can see someone said they saw flashlight. Just said he saw hot dog and toothpaste. So if you go to that link, you can find that toothpaste and you see tons of drawings of toothpastes, right? And these drawings are done by people like you that just went onto the website to draw those things. So if you can even find your drawing there contributing to machine learning research. So the way it does this is we have a lot of images relating this back to our former example, our former definition of machine learning, where we are using data to teach the uh, computer how to recognize things without explicitly telling it, okay, this is how this thing looks like. Okay, so if you go onto the slide and you search for carrot, sorry, let me fix that. If you go into the quick draw data and you search for carrot, you're going to see plenty images of carrot, right? So different doodles, different ways that people are drawing their carrots. So imagine now you're trying to train something. You're trying to get a computer to say, okay, this is a carrot, or if it's not a carrot. Now, what you would do, let's take the non-machine learning approach, right? So what would the non-machine learning approach look like? You'd start looking for features of a carrot, right? So let's say from this drawing now, you can see, okay, you can say something like a carrot when, if there's a pointy side at the bottom, and a more, let's say there's a triangle. Basically, if there's a triangle, it points towards carrot. And if there's something maybe like leaf here at the top, it points towards carrot, right? So now let's tackle this issue using non-machine learning techniques. The first thing we'll do, okay, we'll start saying, we're going to check if the picture, if our object has a triangle inside of it. Okay, that's our first condition, right? So let's say, imagine this was saying if carrot dot or if picture dot triangle is true, then something, and then you check, okay, is there a leaf at the bottom as well, right? So that's how you would do it in using non-machine learning approach, right? So you have to account for every single feature. Now, the problem is, if I write this program and say, let's say our program checks for the triangularity and the leaf, right? And I get my friend Daniel, say, hey, Daniel, come and try my program that is able to distinguish between carrots and non-carrots. So I give Daniel this program and I tell Daniel to draw. Daniel goes ahead to draw. But Daniel, being the human being he is, being unique, he draws his carrot in a slightly different manner. So instead of his carrot being something like this, instead of his carrot being something like this, it ends up being something totally different. Say something like this. Definitely, because our program does not account for that, it's definitely going to fail, right? It's not going to be able to recognize, I'm sorry, it's not going to be able to tell if that is a carrot. Let's just give you a wild guess. Or if Daniel draws something like this. Now, when Daniel drew this, he returned and said, look, hey, I hear your program is not working. Please fix it. And I go ahead and I say, okay, now I'm going to account for this type of carrot. I'm going to say, okay, if it is thin, if there's a line at the end, if there are, say, I believe these are other carrots. If there are other carrots at the side, that's a carrot. Now that is my new rule, right? And say, Daniel, come and test this program again. Once again, Daniel tries to draw another different carrot, and he draws it this time around like this. And this one is looking it's even oval in shape, right? Again, my program is going to fail. So over time, I would discover that, okay, this my approach is not working out. It's not generalizing very well, and the amount of code I have to write is just too much because I have to account for every single detail. Now enter machine learning, right? So remember, what we said about machine learning is, rather than going about saying, oh, these are the rules, this is how you check for something is a carrot or not. No, we just take multiple pictures of carrots, multiple examples, and say, hey, this is a carrot, this one too, this is a carrot, this one too is a carrot, this one is a carrot. So imagine I am a machine learning model now. I see this, right? Oh, I can say, if there's a triangle, if there are lines attached to it, that's a carrot. But then if I see this one again, yes, it maintains that triangle. But even when there are lines here, and this is not really a line, it's more like leaf, something like that, it's still a carrot, right? And even when it changes orientation, it's still a carrot. So it learns to generalize and say, okay, whether this thing is in this form or it's in that form, if it's straight, if it's diagonal, whether it's vertical, it's still a carrot, right? So it learns to generalize. And now, since I use my machine learning model, I say, Daniel, come and draw a new carrot for me. Daniel tried to break my machine learning model, but whatever Daniel tries, I'm safe now. My model is pretty confident, and every time it gets it correctly. Now, the step the step for rule-based or traditional programming would be to frame the goal of your product, right? So the goal here for our example is to distinguish between carrots and non-carrots. The second thing is to develop the flow and logic, right? So this is basically writing all of the rules one by one, checking the triangle, checking the leaves, all in all. And then refine until goals are met. So that is me getting feedback from Daniel and me trying to go back to my code to check all of the conditions. Now, for machine learning, the structure goes like this. We still define our goal, which is to distinguish between carrots and non-carrots, but this time we train a model using examples. So basically, we show a model the examples of what a carrot is, right? And then refinement until goals are met. Now, this we are not doing the refinements this time around. It's the job of the model to do all of that. Now, going on to the next thing, I think now we have a pretty good understanding of how machine learning based projects are and how rule based projects are. So we're going to do a little bit of an exercise now. Um, all right. So I'm going to go to the next slide, and please. So the thing is, we have the task here, and we're trying to determine which approach is best, right? So what you'll do for me is go onto the chat box and type what you think the right approach is to use for this task. So we're trying to alphabetize or sort list of songs based on, we're trying to use the alphabetical order to do that. So what do you think is the best approach? Should we use a rule-based approach or should we use machine learning for this task? I'm waiting for your responses on the chat box. Okay, rule-based. Someone says rule-based. Um, okay, based. Okay, so I think we have a number of votes coming in. Okay, that's awesome. So yeah, it is correct. Rule based is the correct answer. So yeah, so why would we use a rule based approach? Now we're going to use rule based because, so the thing is, we don't really need a machine learning. We don't need something to learn what sorting is. So sorting is a solved problem. You can argue that sorting is a solved problem. There are very good algorithms for sorting, and there are only 26 letters in the alphabet, and so sorting does not require machine learning, right? So what about ranking web search results? Would that be best solved using rule-based approach or machine learning? Hmm. Only one person has voted. Okay, so you're going to be 100% correct if you say machine learning. Okay, but here we have that the answer is two, and I'll give my explanation of why. Right, so yes, if you're trying to if you're trying to if you're trying to arrange it based on relevance to your query, then yes, machine learning is it. But then the one time I would think that rule-based approach would apply very good to this is, say you are searching for something that is related to news, right? And so in that scenario, you would want your research results to be the most relevant, like the most relevant, and that would be like the things that happened most recently, right? So you could sort based on time, and so that again brings us back to sorting, which does not really require machine learning. But then yeah, if you want your results to be very relevant to your query, it's definitely machine learning, right? You're going to have to you should use a machine learning approach. I'm just saying there's an edge case where you would want to add rule based approach to it. Okay, so next one is predicting housing prices based on location. Very quickly, um, to wrap up. Yeah, great. So machine learning, right? Because there are a lot of things that you have to consider when you buy. There are a lot of things that can come into there are a lot of things that are important when you're trying to price a house, right? So the number of rooms, the location, the type, the year it was built, and all of that. So the rules become cumbersome, and rule-based approach is no longer feasible for something like this. So we go with machine learning. Okay. Next up, processing online payments. Should we use a rule-based approach or machine learning for processing online payments? Yes, awesome. So I'm getting responses that should be rule based, and yeah, in fact, that is correct because trying to process payments, I would say it's as simple as a user is trying to buy an item that is X dollars, so it's as easy as removing X dollars from this person's account and putting it into the merchant's account. It's as easy as that. So we don't really need machine learning for something like that. And so rule-based approach would work just fine. But in the case of in the case where we're trying to detect fraud, right, we would go with machine learning. But the answer here is rule-based approach. Okay, I think this is the final one. Classifying an object in a photo. This one. Mm, yes, yes, machine learning. I'm getting tons of ML there. So yes, in fact, it is machine learning. So let's recap. That was quite a lot of information, right? So we talked about what machine learning is. We also talked about rule-based approaches. We talked about machine learning approaches. So just to recap, in rule-based approach, the rules are defined. So the exact steps that the computer has to take are defined for it, right? And the improvements come from algorithms and networks. So whatever whatever logic you use, that is what is going to be used for refinements, right? While on machine learning side, we have the program learn from patterns in the data, and improvements can come from additional data. So the thing about this is that what I aim to show from here is that there are certain cases where machine learning is not the answer, right? It's not always it's not always right that machine learning is the answer. No, there are times when using traditional programming methods is better. So each one has its benefits, each one has its role to play. So next up, so while machine learning offers opportunities, implementing a machine learning system can be more complex than traditional software, right? A rule-based approach sometimes. So this is, sorry, this is primarily because machine learning system is only as good as the data it is trained on, right? So in this section, so we're going to first look at a video, right? Another video. So popcorn time. Yeah. All right.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make.
Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Okay, that was a ton of information. That was a ton of information. I don't know if everyone followed, right? They introduced a lot of concepts there. They went over a lot of things. So first thing I would say is, do not feel intimidated if you did not follow that video entirely. It's totally normal. By the end of this study jam, the entire 3 weeks, you should be able to. That's when I expect that you should follow everything in that video. But for now, let's stick to the main things that we can relate to, right? So looking at this chart now, we have the user to start with. So let's go back to our Batman, Batcave, Batcomputer example. So at that time, we are the user, right? So we define our objective, we give Batcomputer our task, we collect data. So whatever that task is, we have to have data that we're going to give the computer, right? and we train and test on that model. Now, sorry, we train and test the model. This one is done by that computer itself, right? So it learns from the data by itself. And then once we have it's confident about what it has learned, we try to predict and evaluate. So we have
Let's
another
play a
video
game.
at hand.
Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Okay, so we from that video we can see that machine learning systems are not perfect, right? The key takeaway from that video is that your models are only as good as the data that you feed it. It's very important that you curate a very a diverse data set, so that your model is able to generalize very well to whatever task that you're trying to have it learn. So in the next video, we're going to basically see privacy and legal, basically legal stuff, right? So let's have the last video. After the videos, we're
Machine
going
learning
to have
systems
time to
require lots
discuss.
of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
Wow, that was a ton of videos. So let me try to recap what you need to know. So if you look at the last two videos, they focus primarily on the type of data that you feed to your model. Number one is your data has to be diverse, right? So it has to represent every group that you're trying to sort of learn. So let's say you want to learn to recognize carrots and, let's say, baseball bats. So both of those categories, so both carrots and baseball bats, have to be properly represented in your data set. So there has to be at least enough examples of carrots, enough examples of baseball bats for your model to be robust, right? So that's the one part. And then the second part is data privacy. So what it's trying to say is that you can't there's a limit to the kind of data you are allowed to expose to your model, right? So if it's private data, best not to have private data, right? To train your machine learning models, it's best not to have private data. Basically, that's what the last two videos are trying to say. And so, yes, this very very interesting slide. So I'm very sure a lot of you have, if you're not in the machine learning world, if you're not too into the machine learning world, you must have seen something like AI, machine learning, deep learning. Must have seen all of them kind of used interchangeably, right? People just throw around the words, uh any they mix them, basically, is what I'm trying to say. And even though they are similar, there are some subtle differences between each of them. So AI is like the main field, right? And artificial intelligence is basically is attributed to any technology that appears to be doing something smart. So it doesn't even so it can go from even traditional programming methods, as long as that system is behaving smart, or it appears to be behaving smart, it's categorized as AI, right? It doesn't even have to be machine learning. It could be traditional software, but it's categorized as AI as long as it is behaving or it's looking to be behaving smart. Now, machine learning is a specific type of artificial intelligence, but instead of using rule-based approaches, we have the systems learn from data, right? We don't explicitly tell them how to learn; they do it themselves, right? Which is what we've been discussing all through this this session. And then deep learning is another layer inside of machine learning, right? And this one is basically just using something called neural networks. We're going to see neural networks later on, but yeah, that's deep learning. And neural networks just it, it's kind of like an assembly of more and more models, right? So we have models models going from more simple ones to more complex. So, we're going to see all of this fun stuff later on. But yeah, just know this is how the spectrum is. We go from AI and then machine learning and then deep learning. So that brings us to the history, I believe, of machine learning. Now, believe it or not, some decades ago, machine learning was treated kind of like a black sheep, right? And people would make fun of people. Like if you were a researcher, if you were a researcher at that time trying to make machine learning work, people could mock you at that time. People just thought machine learning is never going to work. So development on AI kind of stopped. It was only last few decades that we had enough computing power to be able to run these algorithms. And ever since, machine learning just went boom, 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 right? So let's go on to the types of machine learning that we have. There's something called classification. And just like the name says, we're trying to categorize things into classes, right? So a good example is if you're trying to, if you have a picture of a lion and you're trying to train something that can say, oh, this a lion or is this a tiger, right? Um, it can only be one of two things, lion or tiger, right? That is classification, just putting things into their categories or their classes. And then regression. Now, there's one habit that people in machine learning have, and that is naming stuff in a very complex way so that it sounds complex. In their research papers, people think, "Oh, these guys are doing complex stuff." But if you really look at it, it's very very simple, and regression is just predicting a continuous number. What do I mean by continuous number? It's basically okay. Say we're trying to predict your grade point average, right? So it goes from 1 to 4 or from 1 to 5, right? And the reason why it is continuous is because between 1 and 2, there are numbers. Between 2 and 3, there are numbers. So it could be 1.2, 1.3, 1.4, 1.5. I don't know if you see how if you're able to understand how different this is from classification. So in classification, we just have classes. It could be one of the two things, one of many things. But in regression, it could be in between. Basically, there are in betweens. And then we have clustering, which is basically just trying to group things that are similar together. We're also going to see most of these things in detail. Today is just trying to give you a general overview of these concepts. So that brings me to the end of today's presentation. Um, let's reiterate one more time. We looked at what machine learning is. We looked at the difference between traditional programming and machine learning approaches. We also looked at how to go about from idea to implementation in machine learning. We also looked at different types of machine learning. So subsequently, we're going to go into more details about these things. I know that some of the stuff we went through in this session were a bit complex. We went through a lot of stuff, but hopefully we're going to break them down in subsequent sessions that we have. Um, So quickly, if there are any questions, I'll be taking questions very quickly. I'm trying to wrap up before 9:45. So if there are any questions, I'll be taking questions now. Thank you. Are there any questions? Please ask your questions.
Um, okay, okay. Good evening. So thank you very much for the this thing. I think what we just do is we'll just maybe go on any questions, we'll ask them on the WhatsApp group because of time. You know, we're physically supposed to end by 9:30. So we can just um ask our questions on the WhatsApp group. And for everyone that has registered, send the link to them. And for everyone that is on this call, you get the link right now. So I'll be putting the link in the chat session. So I don't know if you have anything to round up with so that we can just round up quickly. Um, yeah.
Yeah, sure. I don't think there's anything I want to add after this. Um, yeah, we could take questions on the WhatsApp group. That's fine as well.
All right, all right, all right. Awesome, awesome. Thank you very much for the session. It was really, really amazing, and I got to learn quite a lot. Like seriously, from what machine learning is to clustering to rule-based approach to machine learning approach and all of that. It was really, really fun and hey God, English. I think that's also what machine learning does for us. So okay, so yeah, so it was fascinating. And yeah, so I would share the link in the chat session right now so that those everyone who is here can join. And we'll also share since we've gotten people who have registered, we send a mail with the link so that you all can join, and then we'll move further from there. So if you have questions, you can always ask on the WhatsApp group. I just dropped the link right now, so please do well to join. And please let's give our facilitator um, a round of applause for this wonderful session. Please, I want to see your thumbs up. I want to see your claps, emojis, and everything. And let's try to appreciate him for the time. It has actually been such an interesting. I don't know if any other person learned so one or two things. Why I think I learned a lot from the game, from the link that was shared. It was really, really amazing. So yeah, thank you very much. Thank you very much. Thank you, Dairo. Thank you. And thank you all for joining. Thank you all from Nigeria, from Cameroon. It has been an amazing session. I will be having more of these. More details shall be shared with us. More details. You get more details through email, through the WhatsApp group. More these things shall be shared. So thank you all for joining. I don't know if Shekinah is still on the call. If she has something else to say before we put this to a close. Are you there, Shaki?
No, Daniel, I don't have anything to say. Thank you to the facilitator. The explanations were well understood.
All right, awesome. Okay then. Good night, everyone. You have a great night rest. The link is in the comment. The link to the WhatsApp group is in the comment. Please do well to join. I'll drop it again and again. All right. Bye, guys. I think we are done right now. So goodbye. Thank you for joining. Good night, guys. Meet again.